In the year 2026, the heart of the American food supply experienced, well, a catastrophic multi-organ failure. And if you're like most people, you probably watched the news, saw the grocery store prices for wheat and corn violently spike, and you just looked up at the sky,
Right.
wondering why the rain had stopped. But if you were looking at the sky, you were looking in the wrong place entirely. You were looking at the symptom, not the disease.
Yeah, it's a really common mistake. We're totally conditioned to think of droughts as purely atmospheric anomalies, you
It
know?
was bad weather.
Exactly. The clouds disappear, the rain stops, the ground gets dusty. But that completely ignores the actual structural foundation of how a continent keeps itself hydrated.
Exactly. Usually when we talk about a map, especially a map of something as vital as water, there's this, I don't know, this implicit expectation of absolute objective reality.
Yeah.
Feels like an engineering schematic. You pull up a standard map of the U.S., and it looks so simple. It's static. You see these meandering blue lines representing the rivers.
Right. The blue ink.
And you see these nicely shaded, semi-transparent zones indicating where the underground aquifers are supposed to be. And maybe in the dead of summer, you see those colored, blobby polygons on your weather app that represent where the droughts are sitting.
Red for severe, yellow for moderate, yeah.
Exactly. It's clean, it's flat, it's easily digestible.
And it's entirely binary in a way that is incredibly comforting to the human brain. I mean, we really like our complex planetary systems to be visible, neatly categorized, and safely contained on a two-dimensional plane.
Yeah, we want it to be simple.
Right. A blue line means there's a river. A blank space means there is dry land. A red blob means we're in a drought. It gives us this massive illusion of control.
But then you step into the actual physical reality of continental hydrology, and suddenly that flat piece of paper, or that screen, is basically lying to you.
Oh, completely.
We're looking at a diagnostic landscape of our water systems that completely misses the actual point. Okay, so let's unpack this.
Let's do it.
Because our mission for today's deep dives is to completely shatter that two-dimensional illusion of water.
That is the goal. Because the stakes here, I mean, they could not possibly be higher.
Right.
We were fundamentally misunderstanding our water crisis, specifically what is happening beneath the American breadbasket, because we are quite literally observing the wrong dimensions.
Right.
When you only measure the surface, you are guaranteed to misdiagnose the disease.
And we are working off an incredibly fascinating and frankly terrifying source text today. It's a document called The Chug of Water: Rebuilding the Continental Hydrologic Circuit.
It's a brilliant piece of work.
It really is. And its entire premise is that we have to stop seeing water as a flat line on a map. We have to start seeing it as a hidden, breathing, highly pressurized, multidimensional field body.
And that journey, I mean, it's going to take us from the very nature of matter itself.
Which is wild.
Yeah, we're going to touch on quantum physics and geometry all the way to the specific, alarming reality of the stacked 2026 breadbasket drought.
Right.
And finally, we're going to explore a massive civilization-scale solution that basically challenges everything about how we build infrastructure in the modern world.
I was reading through the notes for this, trying to conceptualize just how wrong our standard view is, and the best analogy I could come up with is this.
Okay.
Treating a standard map as the reality of a river system is like looking at a 2D wiring diagram of a house.
Oh, that's good.
Like, the architectural blueprints showing little lines connecting the outlets, and thinking that blueprint helps you understand the actual heat, the pulse, the resistance, and the physical danger of the live electricity running through those walls.
Yeah, exactly.
A blue line printed on paper doesn't have pressure. It doesn't have gravity. It doesn't have electromagnetic cohesion. But the real system out there in the world absolutely does.
That is the perfect framework to start with, honestly.
Yeah.
The blueprint shows you the theoretical path of the current, but it shows you absolutely nothing about the energy state. It doesn't show you the resistance building up in an old wire or the catastrophic failure when the current suddenly overloads the breaker.
Exactly.
So to understand the crisis we're facing right now, to understand what actually broke in 2026, we first have to understand what water actually is as a living system.
Which means moving away from the map.
Right. We have to move our minds from the flat map to the pressurized circuit. And to do that, the source text introduces a specific historical concept to reframe our thinking.
Yeah, and it starts with linguistics, surprisingly enough. It takes us way back. The author introduces this ancient Hebrew word, chug, spelled C-H-U-G, with a little circumflex over the U.
Right.
And the translation of chug is circle, circuit, compass, volt, horizon.
What's really fascinating here is that this word chug It represents a bounded relational field.
Okay, what does that mean exactly?
It means it is not just a geometric ring drawn on a piece of paper with a compass. It is a circuit of active relation.
Right, it's doing something.
Exactly. The concept dictates that water cannot, under any circumstances, be understood as an isolated object sitting in a bucket or a static line on a map.
Okay.
It must be understood as a continuous, dynamic, unbroken circuit.
So walk us through what that circuit actually looks like in the real world, like visually.
Sure. Think of it as an endless relay race of physical state changes. The circuit goes from the moisture in the sky, condensing into snow in the high mountains.
Right.
That snow melts and flows into a high-altitude stream. The stream feeds into a larger river. The river flows down into a regulated reservoir.
Okay, so it's moving through the system.
Exactly. From the reservoir, it's diverted into an irrigation canal. The canal delivers it to the topsoil.
Right.
The soil absorbs it, and gravity pulls it down into the deep, porous rock of the aquifer. The aquifer, over decades, pushes that water back up into a lowland stream through base flow. Then the stream feeds a crop. The crop drinks the water and transpires it out of its leaves back into the atmosphere. The atmosphere gathers it into a storm system, and the storm system carries it back to the land to fall again.
It's a metabolism. It's literally an unbroken loop that acts like the digestive and circulatory system of the entire continent.
Precisely. It is a massive, continent-spanning metabolic system. And when you finally adopt this framework, it forces you to completely redefine what a drought actually is.
Because the standard definition is completely lacking.
Oh, yeah. If you stop anyone on the street today and ask them to define a drought, they will invariably tell you, well, it's when we get less rain.
Sure. Yeah, that's the universally accepted definition. The sky got stingy and stopped dropping water.
But based on the chug, based on the reality of the circuit, that definition is a vast, dangerous oversimplification. Because the water hasn't vanished from planet Earth.
Right.
It hasn't been magically deleted from existence by some cosmic erasure. Drought, in this truer circuit-based sense, is the failure of the circuit to close locally.
The circuit to close.
Yes. The regional body of the land, say, the American Midwest, is spending water.
Right.
It is spending it through intense agriculture, through evaporation off exposed soils, through municipal use and industrial cooling. But it is not receiving that water back in equal measure. The return loop is severed.
It's like a localized bankruptcy. If
Yeah.
I go bankrupt, the money still exists in the global economy, right?
Exactly.
The Federal Reserve didn't distort the dollars, but my specific bank account is draining to zero because my daily expenditures are vastly outpacing my income and my credit line is cut off.
That's a great way to put it.
And you're saying this completely reframes our entire understanding of water scarcity. It shifts it from, oh, we're having a temporary spell of bad luck with the weather, to we are experiencing a catastrophic mechanical failure in our regional loop.
Yes. It is a failure of the chug. The mechanical loop is physically broken. But to understand why that circuit breaks down, and more importantly, what drives the flow of that circuit in the first place, the source text insists that we have to look deeper.
Deeper than the water?
Yes, deeper than the liquid water itself. We can't just look at puddles and rivers. We have to look down to the fundamental forces.
Right.
We have to look down to the quantum level. We have to understand the physics of flow.
Now, I'll be honest, when I was reading this part of the source material, I had to stop and brew another pot of coffee.
It's dense.
Very dense. Because the text goes incredibly deep here. It introduces this underlying principle called field before object.
Yes.
It argues that matter, the stuff that makes up our physical reality, isn't made of dead, inert building blocks.
Yeah.
For instance, an atom of hydrogen isn't a tiny solid marble with a smaller solid marble orbiting it like a child's toy solar system.
Right, that's just a model.
Right. It's actually a probability cloud.
Oh.
At the deeper scales, things like photons are just excitations of the underlying electromagnetic field.
Exactly.
And at the absolute boundary of reality, what physicists call the Planck boundary, things like gravity, quantum action, and the very structure of space-time, all converge into a unified field of relation.
That is the crux of modern physics. The fundamental reality of the universe is not isolated, dead chunks of matter bumping into each other like billiard balls on a felt table.
Right.
The universe is composed of interconnected fields that manifest as matter when they interact.
Okay, I have to jump in and push back here, or at least ask for some serious translation.
Go for it.
Because if I am a listener right now, maybe I'm a farmer out in Nebraska dealing with dust, or I'm just someone living in a suburb watching my local reservoir drop lower every single month. Why do I need to care about quantum probability clouds?
Fair question.
I'm worried about my river channel drying up and my water bill tripling. Why on earth are we talking about the Planck boundary? It feels like we just took a hard left turn into an astrophysics seminar.
I completely understand the whiplash. It sounds like an academic tangent. It sounds like we are losing the thread of the water crisis.
A little bit, yeah.
But I promise you, this connects directly to the dry riverbed, and it is crucial to understand why. Because our current political and engineering management of water treats it as dead stuff.
Dead stuff.
Yes. We treat water like it's a pile of bricks. We think we can just pick it up from point A, drop it at point B, and the job is done. But reality isn't divided into dead categories.
Okay.
The rock of the aquifer, the sand of the riverbed, the liquid water, the vapor in the air, they are all field-structured matter. They are inextricably linked by fundamental forces. They move through gradients.
Okay, I'm listening, but you're going to have to explain what you mean by moving through gradient.
Think of a gradient as a slope of energy. Water never just sits still.
Yeah.
It is constantly being pulled by the physics of its environment.
Right.
The text uses a very specific and admittedly quite obscure physics concept to bridge this gap between the quantum field and the physical water flow.
The Gertzenstein mechanism.
Yes, the Gertzenstein mechanism.
Right. I had to look this up because it sounds like a device from a sci-fi movie. From what I gather, it is the theoretical coupling of electromagnetic waves into gravitational waves under intense magnetic conditions.
Correct.
Which, again, sounds like we were talking about black holes, not the Platte River.
It does sound cosmic. And the thing is, in a standard 1-meter laboratory setting here on Earth, this coupling effect is considered extremely weak, barely measurable, if at all.
Okay.
But the text makes a vital, paradigm-shifting point about scale. Weak is merely a statement about the scale of your observation, not a metaphysical truth about reality.
So scale changes everything.
Exactly. The Earth is enormous. Time is incredibly deep. A tiny quantum effect that is barely measurable in a lab over a fraction of a second becomes structurally profound when you scale it up through massive electromagnetic field lengths, huge photon populations, and cosmic time.
Right. If you take a tiny microscopic whisper of a force, but you apply it across a body of water the size of half the U.S., and you let it run for 10,000 years, that whisper becomes a roar.
Beautifully put.
But let's bring this down to an ELI 5 level. Explain it like I'm 5.
Okay.
How does a theoretical mechanism involving electromagnetic and gravitational waves actually touch a drop of water?
Let's visualize it. Think about the Earth itself. It is a giant magnet. It has a massive magnetic field stretching from the core out into space. Now think about a single water molecule, H2O. It is a polar molecule, meaning it has a positive end, the hydrogen, and a negative end, the oxygen.
Like a little battery.
Exactly. It is like a microscopic compass needle.
Okay, so every single drop of water is full of billions of tiny magnets.
Exactly. Now imagine those billions of tiny magnets sitting inside the Earth's massive magnetic field being constantly bombarded by electromagnetic radiation from the sun and simultaneously being pulled downward by the Earth's gravity.
Wow.
The Gertzenstein mechanism is the conceptual bridge that says these forces aren't ignoring each other.
Right.
The electromagnetic excitation of the sun, interacting with the magnetic field of the Earth, fundamentally couples with the gravitational pull. This creates incredibly subtle but massively scaled physical gradients.
So the author isn't saying that the local creek behind my house is directly, noticeably driven by a laboratory Gertzenstein conversion that I can measure with a stopwatch.
No, not at all. It is a conceptual framework to force us out of our mechanical dead matter thinking. The takeaway for you, listening right now, is a sequence of logic.
Okay, let's hear it.
It goes like this. The fundamental field creates a gradient, a slope of energy.
Right.
That gradient creates motion as the polar water molecules are pulled down the slope. That constant motion over time creates structure. It carves the riverbed, it sorts the sand, it builds the aquifer.
Okay, I follow.
That physical structure then stores energy in the form of pressurized water underground. And finally, that stored energy feeds back into the continuous flow of the circuit.
Field creates gradient. Gradient creates motion. Motion creates structure. Structure stores energy. And stored energy feeds flow.
That is the universal grammar of physical reality, and it applies directly, intimately to water.
So water isn't just a liquid sloshing around in a bowl. The text calls it a polar mass. Its molecules have positive and negative charges. And because of that polarity, its localized molecular behavior is entirely governed by electromagnetism. Like if you take a paper towel and dip the corner in a spill, the water actively climbs up the dry paper against gravity.
Exactly.
That wicking action, that is electromagnetism overcoming gravity at the microscale, how it seeps through a tiny pore in a rock, how it beads up in a perfect dome on a freshly waxed windshield, that is the electromagnetic field at work.
But then, at the macro scale, its large descent, millions of gallons of a river flowing down the Rocky Mountains, is governed by gravity.
Right.
And its behavior in the atmosphere, its buoyancy, is governed by density and thermodynamics.
It is responding simultaneously to electromagnetism, gravity, pressure, and porosity. It is a fielded circuit, is incredibly physically alive, mechanically speaking.
And this is the pivot point, because water is this highly pressurized, multidimensional, field-driven circuit. Our standard flat ways of measuring it, our standard Euclidean geometry that we all learned in high school, are completely hopelessly insufficient to capture what is actually happening.
Which brings us to the next massive paradigm shift in the text. The geometry of the unseen.
Yes.
All right, strap in, because this is where the text actively challenges the very way human beings observe shapes and volumes. The 9-7-13 octahedron.
It's a profound concept.
Let's walk through this carefully, because it blew my mind, but it also took me a few reads to grasp.
It is counterintuitive to how we are taught to see the world. We need to visualize the shapes first.
Let's do that. The author talks about standard classroom geometry versus what they call a living field count.
Right.
So if you're listening, picture an octahedron in your mind. If you play Dungeons & Dragons, it's an 8-sided die.
Great analogy.
If not, picture 2 identical square-base pyramids like the pyramids of Egypt, but you glue them together perfectly at their flat square bases. You get a diamond-like shape pointing up and pointing down.
That is a perfect visualization. Now, how does a standard geometry teacher count the parts of that shape?
Standard exterior geometry, what the source text calls the shell count, tells us an octahedron has 8 flat triangular faces.
Right.
It has 6 vertices, which are the sharp points where the lines meet, and it has 12 edges, which are the straight lines connecting the points.
Correct.
So the mathematical shell count is 8, 6, 12. Faces, vertices, edges. But the source text says this high school math is incomplete.
Very incomplete.
It introduces the living field count, which changes the numbers to 9-7-13.
Yes.
It has a center source face, center source vertex, and most importantly, a hidden inner source 13th edge.
This is where we have to abandon the hollow shell mentality.
But wait, let me play the highly skeptical classroom geometer here.
Please do.
Because if I am holding that 8-sided die in my hand, I'm looking right at it. I can run my thumb over every single part of it. I count 12 edges.
Right.
You can't just mathematically invent a 13th edge out of thin air. A shape is a shape.
Yeah.
The empty center of a 3D object isn't literally an exterior line segment. It's not a physical panel you can touch. How on earth does the author justify adding a 13th edge to a shape that clearly only has 12?
I love that pushback because your skepticism is exactly what the text anticipates. You are having the exact reaction a structural engineer would have.
Good to know I'm not crazy.
Not at all. But the author's response is that your objection only works from the outside perspective.
Yeah.
You are implicitly assuming the shape is just a hollow, empty shell sitting in a vacuum.
Okay.
But in the physical quantum universe we just discussed, an absolute outside doesn't exist. There is no such thing as an object completely divorced from its internal and external fields.
Okay, walk me through that.
Think about what empty space actually is. The center of that octahedron isn't nothing. It is the relational condition that makes the exterior shell possible in the first place.
Interesting.
You cannot define an outer boundary without simultaneously defining an inner volume. The boundaries only have physical meaning because there is a within.
Ah. So the outer boundary is essentially acting as a container.
Precisely. Let's step away from the abstract geometry and use a physical analogy.
Okay.
The text initially makes you think of the volume as the essence of the shape. Let's upgrade the metaphor. Don't think of a balloon, which is just a thin skin of rubber holding a pocket of air that's too fragile.
Right. Pop it and it's gone.
Exactly.
Yeah.
Think of a massive, dense, waterlogged sponge.
Okay. Spun.
Now imagine taking that heavy, wet sponge, placing it on the ground, and dropping a heavy brick on top of it.
Okay. The sponge is going to compress and the water is going to squeeze out the sides.
Exactly. The sponge is the earth. The water inside it is the hidden volume, the 13th edge.
Oh, I see.
The brick is the millions of tons of bedrock and topsoil pressing down from above. As long as that hidden volume of water is inside the sponge maintains its height.
Right.
It pushes back against the weight of the brick. The structural integrity of the entire system, the 12 outer edges, is supported by the pressure of that hidden 13th edge inside.
I see exactly where this is going. If you stick a straw into that sponge and suck the water out from the inside, the hidden volume disappears.
Yes.
And what happens to the sponge? The immense weight of the brick crushes it flat.
And once it is crushed flat, even if you pour water over it later, it can't hold as much. The physical structure of the empty space has collapsed.
Wow.
So in the living field count of geometry, the 12 exterior visible edges are literally held together, relationally and physically, by the 13th inner edge, the pressurized hidden volume.
Okay, so let's take this 9-7-13 sacred geometry and translate it into actual physical hydrology. How does this apply to the real world?
It maps onto our infrastructure perfectly. The aquifer, the ancient water stored deep underground beneath our feet, is that hidden volume.
The 13th edge.
Yes, it is the pressurized 13th edge. The river that you can see flowing on the surface of the earth, the one you drive your car over on a bridge, that is merely the exposed edge of the geometry.
Okay.
And the reservoir, like a giant dammed lake, is the regulating node, the vertex connecting the edges.
So what does this actually mean for our understanding of a drought? Because this completely changes the diagnosis.
It means everything. It means that when you look at a riverbed and it is dry and cracked, that is not just a surface fact.
Right.
It is not just a localized failure of the exposed edge. A dry river means the shell face of our geometric reality is showing you a much deeper, hidden volumetric failure.
The center is collapsing.
The center is collapsing. The hidden 13th edge, the aquifer beneath, it's so depleted that the pressure has dropped. It can no longer support the 12 exterior edges above it.
Wow.
The river is dry because the underground sponge has been sucked empty and the earth is compressing.
The hidden foundation is crumbling, so the roof is caving in.
Exactly.
Which means we can't just pray for a rainstorm to fill the riverbed. A puddle on a collapsed roof doesn't fix the foundation.
Exactly. And once we understand this theoretical framework of the 13th edge and the pressurized hidden volume, we have to stop talking in abstract terms.
Time to look at the real world.
Yes, we have to look at the actual physical hidden volume that is currently supporting the American breadbasket. We have to look at the anatomy of the Platte River and the High Plains aquifer. We have to look at the patient on the operating table.
Right. We've built the theory. We've covered the physics and the geometry. Now let's look at the actual flesh and blood of the continent,
The High Plains aquifer.
which is commonly known to most people as the Ogallala. I think a lot of people picture an aquifer, and I certainly did before reading this, as this massive, cavernous underground lake.
Right.
You picture it like an underground river pipe or a giant subterranean cave where you could launch a rowboat in the pitch dark and paddle around on an underground sea.
That is a very common and highly destructive misconception.
Why is that destructive?
Because it leads people to think we are just dipping a straw into a giant underground swimming pool. But it's not a hollow cage. The Ogallala is a vast, incredibly dense, complex, porous mineral body.
Okay.
It is made of rock, tightly packed sand, and ancient gravel. The water isn't sloshing around in a void. It is held in the microscopic spaces, the tiny pores between those billions of grains of sand and rock.
It's that dense sponge we talked about earlier.
Exactly. And this saturated mineral body is unimaginably huge. It stretches beneath parts of 8 different states.
Colorado, Kansas, Nebraska, New Mexico, Oklahoma, South Dakota, Texas, and Wyoming.
Right. It is the buried ocean that feeds the world.
And here's where it gets really interesting and frankly, deeply concerning.
The numbers.
Yes, the source text provides hard data from the United States Geological Survey. It looks at the timeline from pre-development, which essentially means before human beings started heavily pumping it with modern gas-powered machinery and deep wells,
Right.
up to the year 2019. In that time frame, the High Plains Aquifer experienced an area-weighted average water level decline of 16.5 feet.
We need to pause and absorb that number.
It sounds kind of small at first, 16 feet.
Right, but a decline of 16.5 feet across a continuous underground body that spans 8 states.
Yeah, let's do the math on what that actually means in terms of physical volume, because the text spells it out. That 16.5-foot drop equates to a staggering loss of 286.4 million acre-feet of recoverable water.
It's unbelievable.
That is water that is simply gone from the hidden volume.
And it is hard for the human brain to conceptualize a number like 286.4 million acre-feet. Let's break it down.
Please do.
An acre-foot is the amount of water it takes to cover one entire acre of flat land exactly 1 foot deep in water. In liquid terms, it's roughly 326,000 gallons.
All right.
That is 1 acre-foot. Now, multiply 326,000 gallons by 286.4 million. You were talking about trillions and trillions of gallons of water.
Oh, wow.
If you pulled that water up to the surface, you could drown entire states. That is the sheer scale of the hidden depletion of the interior body beneath the American breadbasket.
That is the 13th edge violently collapsing under our feet over the last century.
Yes.
And out of those 8 states sitting on top of this collapsing sponge, the text places a massive laser-focused emphasis on one state in particular.
Nebraska.
Nebraska. It calls Nebraska the central hydrologic hinge of the northern High Plains body. Why Nebraska? Why is that the critical fault line?
Because of the unique, almost magical way the geology and the surface water interact in that specific location, it is what the author calls the mouth-head interface.
Oh, we can explain that.
Think about the geography of Nebraska. You have the sandhills. These are enormous, ancient sand dunes that have been stabilized over thousands of years by deep-rooted prairie grasses.
Right.
Because it's sand, it is incredibly porous. When it rains or when snow melts, the water doesn't just run off into a muddy ditch. It soaks straight down deep into the earth. It is a massive infiltration zone.
It's like a continent-sized water filter.
Yes. And flowing right through this massive infiltration zone, you have the Platte River system. You also have Lake McConney, which is a massive engineered reservoir on the North Platte.
Okay.
And feeding all of this, you have the mountain snowpack melt coming in from the high elevations of Colorado and Wyoming. Nebraska is the geographic hinge point where the buried, hidden water body, the Ogallala, and the visible, exposed river body, the Platte, are placed in intense, pressurized physical conversation with each other.
So going back to our geometry, Nebraska is the exact point of connection where the 13th hidden edge and the visible surface edges overlap and exchange energy.
Precisely. The underground volume, when it is healthy and pressurized, expresses itself through the visible rivers. The water table is so high that it pushes water up from below, filling the riverbed even when it hasn't rained.
That's base flow.
That's called base flow. And conversely, during wet seasons, the visible rivers and the rains seep downward through the porous sand to recharge the underground volume. It is a two-way street. The mountain snowpack in Colorado is the charge, the fresh kinetic energy entering the system. Lake McConney in Nebraska is the battery, the regulating heart that stores that mountain charge.
Okay.
The Platte River is the transit corridor, and the massive underground Ogallala volume is either recharged or drained, depending entirely on the delicate, fluctuating balance of this hinge in Nebraska.
Which perfectly, tragically sets the stage for the crisis at hand.
It does.
We know the system is deeply interconnected. We know it operates as a localized metabolic circuit, a chug, and we know, based on the USGS data, that the hidden volume, the Ogallala, is already severely depleted.
Severely.
It is short hundreds of millions of acre-feet.
Yeah.
The structural foundation's already cracked. So the ultimate question is, what happens when a massive, multivariable, compounding stress test hits a system that is already weakened and dehydrated?
Enter the year 2026.
Enter 2026.
This is where the theoretical danger we've been discussing becomes a terrifying, immediate reality. The statistics coming out of the 2026 drought are not just indicative of a bad year for farmers. They are the vital signs of a structural breakdown.
Let's walk through these grim numbers because they paint a terrifying picture. First, the setup.
The winter.
Right, the winter leading into the 2026 growing season, specifically December 2025 through February 2026, was Nebraska's second warmest and fourth driest winter on historical record.
So the baseline is hot and bone dry.
Exactly. Then we look at the charge coming from the mountains, the snowpack.
Right.
The North Platte Basin snowpack in March 2026 had, and I am quoting directly from the source text here, no modern analog.
That phrase.
It was so exceptionally bad that even the absolute next worst year on the historical record was 3 entire inches higher in water equivalent.
I really want you to hear that phrase, no modern analog. When hydrologists and meteorologists use language like that, it should send shivers down the spine of anyone who relies on food to live. This wasn't just a low snow year. The atmospheric storm tracks completely shifted far to the north, missing the critical basins. And because the winter was abnormally hot, whatever little snow did fall was melting incredibly early.
Explain why that early melt is so devastating. Like, why does it matter if the snow melts in March instead of June, as long as the water eventually comes down the mountain?
It's all about the thermodynamics of the landscape and the timing of the chug.
Okay.
Mountain snowpack acts as a frozen reservoir. It is nature's perfect battery. It holds millions of gallons of water locked in ice, high in the cold atmosphere, and slowly, gradually releases it throughout the hot summer, exactly when the valleys below need it most for agriculture.
If it melts early.
If that frozen reservoir melts in March before the planting season even begins, the water rushes down the transit corridor way too early.
Right.
It evaporates, it flows out of the regional circuit, the kinetic charge is completely spent before the system's demand even peaks.
And because the mountain charge failed, the engineered battery downstream was dying.
Yes.
Lake McConney, that vital regulating heart in Nebraska, entered the 2026 season at an abysmal 51% capacity.
Which is terrifying.
For context, that is nearly 30 percentage points below its typical historical average for that time of year. It's starting the marathon with half a tank of gas.
Barely half a tank.
And then you look at the drought.gov data, and the geographic spread of the aridity is just catastrophic. 93.9% of the entire state of Nebraska, 96.2% of Colorado, 98.2% of Wyoming,
Wow.
all officially in severe drought. Colorado's headwaters were running their 6th driest January to April period on record. Wyoming was the 4th driest.
This is exactly why we have to view this crisis through the lens of the circuit, the chug.
Because it's everywhere.
Right. If you look at this as just bad weather, you miss the architecture of the collapse. This is what a whole body failure looks like. Look at where that red drought blob is sitting on the map.
Where is it?
It is sitting heavily across the high-altitude source in Colorado and Wyoming. It is sitting across the transit corridor of the rivers, and it is sitting directly on top of the receiving basin and the hidden volume in Nebraska.
It's choking the entire system simultaneously.
Exactly. The frozen charge is dying, the liquid battery is dying, and the surface transit is evaporating into a hot, dry atmosphere.
It's failing simultaneously at every single node of the circuit. Now, human nature is predictable.
Very.
Whenever we hear statistics this horrifying, our immediate instinct is to look back at history.
Right.
We seek comfort in the past. We want to say, well, we survived bad things before, we'll survive this.
Oh, definitely.
People will immediately point to the history books and say, what about the Dust Bowl in the 1930s? The sky literally turned black with dirt. Surely it was worse back then.
Right.
Or what about that massive drought back in 2012 that ruined the corn crop?
Oh.
Let's do a comparative diagnosis of these historical events to see why 2026 is uniquely terrifying.
Looking at history is vital, but as the source text makes explicitly clear, the comparison must be done by looking at the underlying mechanism of the drought, not just by throwing around historical slogans.
Okay, let's look at 1934, the absolute peak of the Dust Bowl.
Sure.
NASA climate data confirms that 1934 was undeniably the driest and most widespread atmospheric drought in North America in the last 1,000 years.
Unprecedented.
It was roughly 30% more severe than the next worst year on record, covering over 70% of the western half of the continent.
Right.
Okay, that sounds unbeatable, right? That sounds like the absolute apex predator of droughts, the worst case scenario.
It was a generational catastrophe, absolutely. Millions of lives were ruined. But we have to ask, what was the physical mechanism of that catastrophe?
Okay.
The 1934 drought was fundamentally a topsoil and atmospheric failure.
Topsoil.
Yes, a persistent winter high-pressure ridge turned away the Pacific storms, kicking off the dry spell. But the severity, the apocalyptic dust storms, that was massively amplified by human action, specifically terrible land management.
Right, the homesteaders had moved in and aggressively plowed up millions of acres of virgin prairie.
Exactly. The native prairie grasses had deep, incredibly tough root systems that held the soil together and trapped moisture deep underground, acting like a protective skin.
And then the plows came.
When the plows ripped all that up to plant shallow-rooted wheat, they destroyed the living skin of the land. When the rain stopped, the loose, naked topsoil simply blew away.
I try to conceptualize the 1934 Dust Bowl as a catastrophic third-degree sunburn.
Oh, that's a good way to look at it.
The protective surface skin of the Earth was completely destroyed, exposed, and burned to a crisp. And once the dust storm started, it created a vicious feedback loop.
Right, because of the dust in the air.
Yeah, the dust blocked the solar energy from hitting the ground, which changed the thermodynamics of the atmosphere and literally suppressed the formation of rain clouds. It was a terrifying surface loop.
A great analogy. A third-degree sunburn is horrific, but the 2026 crisis is fundamentally different.
How so?
2026 is deep organ failure. In 1934, the surface was destroyed, but the hidden volume, the massive Ogallala sponge, had not yet been tapped by modern industrial-scale center pivot irrigation.
Oh, wow. didn't think about that.
Yeah, we didn't have the technology to drain it deeply yet. The baseline underground health was vastly superior. Lake Makani didn't even exist yet to mask the surface water shortages.
The 13th edge was still intact.
The underlying body was intact. In 2026, the sunburn is accompanied by severe internal bleeding.
Okay, what about the drought era from 2004 to 2006? I remember reading about Lake Makani hitting historic, terrifying lows back then. Marinas were sitting in dry dirt.
That era was what we would call a managed storage drought geometry.
Managed storage.
Yes, the lake was incredibly low, but it highlighted the highly engineered nature of the basin. Upstream in the basin, massive increases in groundwater pumping and aggressive new conservation measures had significantly reduced the amount of physical water flowing downstream into the lake.
Right, because it was being intercepted.
Exactly. It resulted in the Platte River officially being declared overappropriated, meaning we had legally promised more water on paper than actually existed in reality. So, while it was dry, it was fundamentally a reservoir rights problem and a management crisis inside a heavily engineered plumbing system.
And then there's the drought of 2012. The text refers to this specifically as a flash drought.
Yes, 2012 was shocking to the agricultural community because it came right on the heels of the massive destructive floods of 2011.
Oh, right.
The system went from overflowing to bone dry almost overnight. It was driven by a persistent, stubborn, high-pressure ridge in the atmosphere, combined with intense heat, high winds, and specific changes in solar radiation.
Okay.
Those factors combined to rapidly, violently strip the moisture out of the landscape during the middle of the summer. It was an intense atmospheric clampdown.
But how is that different from 2026?
Crucially, it did not begin with the same underlying structural failure of the winter-spring mountain snowpack that we were witnessing in 2026. The battery wasn't empty before the race began.
So when we synthesize all this historical data, the sunburn of 1934, the management crisis of 2004, the flash fry of 2012, why does the source text categorize 2026 as its own monster category?
Because 2026 is a stacked compound failure. It combines the absolute worst elements of every historical disaster.
All at once?
Yes. You have a historically abysmal snowpack, meaning the fresh source charge is compromised. You have weak storage in the vital reservoirs, meaning the buffer is gone. You have a widespread, multi-state atmospheric drought mimicking the vast geographical footprint of 1934.
Right.
And most critically, the fatal blow, you are hitting a severely depleted, structurally compromised long-term aquifer baseline. Those hundreds of millions of acre-feet we've lost since pre-development mean the underground sponge cannot push back against the pressure.
It's like a medical patient having a massive heart attack, complete kidney failure, and catching a severe respiratory infection all in the exact same afternoon,
Exactly.
while their immune system is already completely compromised from a chronic disease.
Exactly. It is a compound, multidimensional hydrologic geometry of failure. It is the 13th edge collapsing while the 12 exterior edges are on fire.
But even when presented with this mountain of data, human psychology is incredibly resistant to bad news.
Of course.
People desperately want to ignore the magnitude of the problem to protect their livelihoods and their peace of mind. The source text anticipates these rebuttals, these common logical-sounding excuses that politicians, water managers, and citizens use to avoid facing the terrifying reality of the broken circuit.
Yes, it does.
Let's play devil's advocate. Let's dismantle these rebuttals one by one. Rebuttal number one. Look, droughts have always happened in the West. It's just a natural weather cycle. We will bounce back.
This is the most common dismissal, and it relies on a fundamental, fatal confusion between a temporary weather event and a chronic system condition.
Right.
Yes, droughts are natural atmospheric events. They have happened for millennia. But structural dehydration is an entirely different beast.
Back to the sponge.
Let's go back to our sponge analogy. A natural drought striking a fully charged system, a thick, healthy aquifer, full reservoirs, robust, root-dense soil moisture results in a tough season.
Okay.
The system buffers the shock. The sponge is thick enough to survive the weight of the brick for a while, but when that exact same atmospheric drought strikes a structurally dehydrated, depleted system, it doesn't just cause a bad harvest, it causes collapse.
Right.
The drought is just the weather. The dehydration is why the body can no longer survive the weather.
Okay, let me throw rebuttal number two at you. I'm looking at the geological maps of the Ogallala.
Yeah.
I see the red zones of depletion, sure.
Yeah.
But I also see areas, particularly under the sandhills of Nebraska, where there are still hundreds of feet of saturated thickness. There is a massive amount of water still down there.
There is.
A skeptic is going to look at that map and say, we have a massive buffer left.
Yes.
The sky is not falling. we're fine for another 100 years.
This raises an important question. If you own a massive industrial-grade battery, but you plug in a device that is relentlessly draining the power 10 times faster than it is being recharged, does the sheer physical size of that battery make you permanently invulnerable?
No.
Yeah.
The math is undeniable. It just means you have a little bit more time on the clock before the lights go out completely.
Exactly. And this is the great fallacy of volume. Remaining storage is not a license to maintain a deficit. Remaining storage is not a license to keep draining.
Right, you have to protect it.
Remaining storage is precisely the structural integrity that must be fiercely protected. If the hydrologic hinge in Nebraska starts to fail, if the physical pressure drops so much that the surface river stops flowing and the base flow reverses, the fact that there is still some wet rock 1,000 feet underground doesn't save the local ecosystem.
Right.
It doesn't save the local farms whose shallow wells run dry.
Right, because they can't reach it.
When the pressure drops, the structure compresses and the chug is broken regardless of the remaining deep reserves.
Right. It's not just about having water. It's about having water under enough pressure to make it accessible to the living skin of the earth.
Precisely.
And that brings us to rebuttal number 3. I think this one might actually be the most insidious because it sounds so incredibly responsible and green.
Conservation.
The rebuttal is conservation will fix it. We don't need panic. We just need efficiency. We need more precise center pivot sprinklers. Cities need to ban watering lawns. We need to plant genetically modified, drought-resistant crops. We can conserve our way out of this.
I want to be very clear here. Conservation is absolutely, undeniably necessary. It is morally and practically required of us.
Of course.
We cannot waste water. But the hard, unvarnished truth from the source text is this. Conservation only slows the bleeding. It does not refill the body.
Wow.
If your mountain snowpack is vanishing due to climate shifts, if your reservoirs are half empty, and if your underground aquifer has already permanently lost 280 million acre-feet of volume, reducing your agricultural demand by 10% or even 20% does not magically create new water.
Right. It doesn't add anything back.
It does not replace the lost volume. If the chug is fundamentally broken, if the return loop of the circuit is severed, efficiency just means you are draining the system toward death slightly slower.
You are stretching out the bankruptcy, but you are still going bankrupt.
Exactly.
Which brings us to the ultimate staggering question of this entire deep dive. We've proven the map is a lie. We've defined the circuit. We've watched the 2026 collapse.
Yeah.
We've ruled out conservation as a complete saving fix. We've established that the entire breadbasket system is structurally dehydrating toward functional aridification.
You mean desert?
Right, meaning without intervention, it is slowly, mechanically moving toward becoming a functional desert. So what is the actual cure? If we can't save our way out, how do we build our way out? What is the civilization-scale solution?
The solution requires us to confront the fundamental philosophical flaw in how America built its water infrastructure over the last 150 years.
Okay, what's the flaw?
We built an unparalleled empire of extraction. We built millions of high-powered wells. We laid thousands of miles of concrete canals. We built massive municipal pumping systems.
Yeah, amazing engineering.
Yes, all of this brilliant engineering was designed to do one thing: pull water out of the hidden volume in the surface rivers as fast as possible.
Right.
But we completely, utterly failed to build a continental return infrastructure.
We essentially built a massive, multi-lane, one-way street heading straight out of town and forgot to build a lane coming back.
Exactly. We extracted the capital and never reinvested the dividends. And the text argues that the only way to save the breadbasket from eventual aridification is to finally build the return lane.
What does that look like?
And that means constructing a modern, continental-scale aqueduct architecture, but it has to be understood correctly or it will just cause a political civil war. It does not mean stealing fresh water from the Great Lakes or piping the Mississippi River to Nebraska. Doing that just shifts the vicious logic of depletion from one inland basin to another. You rob Peter to pay Paul, but both are still going bankrupt.
So where on earth does the massive volume of water come from, if not from another river?
It has to be net new water added to the continental system.
Net new.
And on planet Earth, there is only one source for massive net new water: the ocean.
Wow.
The solution posited by the text is the construction of massive coastal and Gulf Coast desalination infrastructure connected to inland delivery systems.
Now, I want to pause and clarify a highly specific point the text makes because it's a vital distinction that comes up in water policy debates all the time.
Yes, it does.
Some people argue we don't need the ocean. They say, look, there is highly saline, brackish water trapped deep, deep underground in the Midwest, below the fresh water.
The deep saline aquifers,
Right.
right?
Yeah. Let's just build inland desalination plants, pump up that dirty deep water, clean it, and use it. But the expert source completely shoots that idea down.
Yes, and it shoots it down for a very mathematically logical reason. Inland brackish water desalination doesn't solve the structural deficit of the chug.
Why not? You're cleaning water.
It's an illusion of new water.
Yeah.
All you are doing is taking dirty water that is already physically inside the failing geographic basin, cleaning it, using it on crops, and letting it evaporate away into the atmosphere.
Oh, I see.
You are still ultimately draining the overall physical mass of the continental volume. The weight of the brick is still going to crush the sponge. To restore the pressure, we need actual net new physical mass brought in from the outside.
So what does this all mean for our reality? If we follow this logic to its conclusion, it means a mind-boggling level of infrastructure.
Unprecedented.
We are talking about colossal nuclear or renewable power desalination hubs sitting on the Gulf of Mexico or the Pacific coast.
Right.
And then we are talking about massive engineered rights-of-way, pipes, canals, lifting stations, moving billions of gallons of that water inland. But I have to push back here.
Go ahead.
Do you know how much electricity, how much kinetic energy it takes to pump water 5,000 feet uphill over a distance of 1,000 miles?
It's massive.
It is an astronomical economic and energetic cost. Are we seriously suggesting this is viable?
It is an astronomical cost, but compare it to the cost of losing the agricultural output of the American Midwest.
True.
Compare it to the global starvation and economic collapse that would follow the functional desertification of the breadbasket. We built the interstate highway system.
Right.
We built the Hoover Dam. We went to the moon. Building a continental water return system is the requisite infrastructure project of the 21st century.
Okay, so how do we actually do it?
The text introduces a brilliant, paradigm-shifting new motto for how this water must be used. Aqueduct to the aquifer, not merely aqueduct to the faucet.
Aqueduct to the aquifer. Let's
Yeah.
break that down.
That motto is the key to surviving the century. Our current infrastructure paradigm says that a municipal supply pipe just gives humans water to consume, put down the drain, and flush away.
Right. It's for immediate use.
Exactly. But an aqueduct to the aquifer is fundamentally different. It is designed to heal and restore the geological water body itself.
So we're not just drinking it.
No, the net new ocean water isn't just being piped into a city for drinking. It is meant to be pumped into vast, engineered midpoint recharge basins. It is meant to be pumped into restored wetlands.
Okay.
It is meant to be forced down into deep, pressurized injection wells directly into the Ogallala.
It's meant to augment the failing river-based flows and artificially stabilize the water levels of Lake McConney so we don't have to keep draining the underground reserves.
Precisely. It is literally putting physical mass back into the 13th edge.
Putting water back in the sponge.
It is injecting water back into the sponge so it can push back against the weight of the earth. If we just continue to furiously consume the local breadbasket loop, if we extract the local water to grow corn, soybeans, feed, and fiber, and then we export those physical products out of the region to feed the rest of the world,
The water leaves.
the water leaves the physical system permanently. It is gone. Without an engineered return loop pushing mass back in, the land structurally inevitably dries. We have to artificially, deliberately rebuild the local chug using the endless volume of the ocean.
Okay, let's take a breath and pull all of this immense information together. We have covered incredible ground today.
We really have.
We started by throwing away our flat, comforting, two-dimensional maps. We dove into the quantum reality of water, understanding how the Gertzenstein mechanism and electromagnetic fields create the motion and structure of our rivers.
Yes.
We moved our minds into the 9-7-13 living geometry, uncovering the vital, pressurized necessity of the hidden volume, the aquifer.
We looked under the soil of the American breadbasket and saw how the massive multi-state Ogallala sponge connects intimately to the Platte River at the Nebraska hinge. And we saw how the stacked, compounding, horrific drought of 2026 pushed that delicate hinge and the regulating battery of Lake McConney to the absolute brink of whole system failure.
proving once and for all that these modern mega-droughts are not just a season of bad luck with the clouds, they are structural collapses of a dehydrated body.
Exactly.
And finally, we explored why simple conservation alone is mathematically doomed to fail, and why a massive, unprecedented coastal to inland return aqueduct, literally pumping the ocean uphill to the aquifer, is the only way to physically close the circuit, restore the pressure, and save the breadbasket from turning to dust.
If there is one single thing you take away from this entire analysis, let it be this. When you hear about a drought on the news from now on, when you see those red blobs on the map, do not just look up at the sky hoping for rain.
Yeah,
The answer isn't just in the clouds anymore. Look down beneath your feet. Think about the hidden volume. Think about the pressure. Remember the chug. Remember the circuit.
beautifully said. And I want to leave you, the listener, with a final provocative thought to mull over as you go about your day.
Okay.
We talked earlier about the living skin of the land being ripped up during the 1934 Dust Bowl. Well, think about our human infrastructure as a kind of skin.
That's interesting.
If our entire magnificent continental extraction infrastructure over the last 150 years was built purely on the psychological and economic logic of endless taking, a giant one-way street of consumption,
Right.
what profound, painful, psychological and political shifts are going to be required for our society to pivot to an economy based on returning?
Wow.
If water is the literal physical lifeblood of the continent, will the future heroes of the breadbasket be the farmers tilling the soil or the engineers who figure out how to successfully pump the ocean 5,000 feet uphill?
That is the question.
We have to decide what kind of ancestors we want to be. Food for thought. Thanks for joining us on this deep dive.